Hello students, welcome to Educate. In the last video, we have discussed about electrolytic cells. The concepts we have discussed, and based on that concept, a number of questions frequently asked in 12th board examination as well as in IIT main, advanced and the NEET examination. And nowadays for the CUET examination, a number of questions may also ask from this topic, and particularly the numericals. Let's see the first numerical here. Their question is here, given CuSO4 electrolyte for 10 minutes, current is passing 1.5 ampere, and it is asking mass of copper deposited at the cathode. Very simple here. 1.5 ampere current has been passed for 10 minutes. You know already current is equal to charge by time. Current, when it will be in ampere, charge will be in coulomb and time in second. So here current is 1.5, so total charge passed through the solution is IT. Current 1.5 ampere, so that much ampere into charge. Time here is in minutes, so you have to convert this time in second, because the unit of current will be ampere when charge will be in coulomb and time is in second. That means 1 ampere is equal to 1 coulomb per second. So here current has been given in ampere, so you have to take time in second. So second here 10 minutes, so convert it to seconds, so 10 into 60, that much second, that is equal to 900 coulomb. Okay, very simple here. That means through the solution 900 coulomb of charge has been passed. Now let's see on the CuSO4 that will dissociate into Cu2 plus and SO4 2 minus. Charge here is 2 plus. So that's why when 2 into 96,500 coulomb, when 2 into 96,500 coulomb charge will pass, then 1 mole copper, will deposit. When 2 into 96,500 coulomb of charge will pass through the solution, then 1 mole copper will deposit. Because charge on copper is 2, that's why 2 into 96,500 coulomb. This is the concept. Whatever be the charge on cation or the anion, that into Faraday's constant, and Faraday's constant 96,500 or 96,483, whatever you would like. For the sake of simplicity, I have taken 96,500 coulomb. Faraday's constant, I have taken 96,500. You may take 96,483 also. So that much when charge passed through the solution, then 1 more copper deposited, means mass of copper deposited. So let's see here also, mass of copper deposited 63 gram. Let's see here also. Now that is when 900 coulomb charge will deposit, then how much copper will deposit? So 1 upon 2 into 96,500 into 900. This one cancel out. Now divide 9 by 2 into 968. This one 2 into 968. That much mole of copper will get deposit. Now weight of 1 mole copper will be 63 gram, because atomic weight of copper is 63 gram per mole. Atomic weight of copper is 63 gram per mole. That's why atomic weight of here atomic weight of copper is 63 gram per mole. So when the number of moles of copper will be 63, when the number of moles of copper will be 1, then their weight will be 63 gram. And number of moles of copper you have here, the number of moles of copper deposited will be equal to 9 upon 2 into 958. So that will be, so weight of 9 into 9 into 1. So we have 1 only, 2 into 2, 965. 965. So 2 into 965. That much mole of copper will be how much? 63 into 9 upon 2 into 965. That much in gram. So when you will multiply, you will do the calculation, that will be 0.23, near about 0.29 gram. So when a current of 1.5 ampere will pass through the solutions through 10 minutes, then 0.29 gram of copper will deposit at the cathode. Clear, guys? Not only this question is important, other questions is also important, and particularly of the exercise question, which has been frequently asked in 12th board examination also, and more important than 12th board examination is for IIT main and the NEET examination. So, and those questions are very easy. We will discuss from the beginning. Let's see here. Last questions are too much important. Let's see here. This question about similar questions related to this one we have discussed already. This is related to the graph, and to solve this graph, to solve this question, you will have the requirement of a graph paper, and very simply you can find out this one. Next question here is given. Conductivity of this much molar acetic acid is that much. Calculates its molar conductivity, and limiting molar conductivity has been given. You have to find out dissociation constant. About that, this question also we have discussed, 2.11. Of this question, I am solving one question. Remaining questions you solve by yourself. Of one questions I am solving. Listen here, how much charge is required for the following reactions? 1 mole of Al3 plus 2 aluminium. So obviously here 1 mole. So aluminium here it is in +3 oxidation state. That will have to go in 0 oxidation state. So here oxidation number, okay, +3, and that will go in 0 oxidation number. So 3 Faraday charge will require, or 3 into 96,500 coulomb of charge will require. This one. Now remaining 2 questions you solve by yourself. Now second question, how much electricity in terms of Faraday is required to produce 20 gram of calcium from molten CaCl2. So calcium you will have to deposit. So CaCl2, that dissociate into Ca2 plus and 2 moles of Cl minus. So when 2 Faraday charge, or 2 into 96,500 coulomb of charge will pass, then 40 gram calcium will deposit. So 40 gram will deposit by passing 2 Faradays. So 20 gram will pass through, 20 gram will deposit by passing 1 Faraday charge, or 96,500 coulomb charge. Okay. Second question you solve by yourself. How much electricity? 2.14. Listen. 2.4. How much electricity required coulomb for the oxidation of 1 mole of H2O to O2? Listen here, H2O. Here H2O. So here oxidation number of oxygen is -2. Here oxygen oxidation number is 0. So balance H2O that distributed into here and H2. Balance the equation. So 1 mole of H2O you will have to reduce. So 2 into 96,500 coulomb of charge when passed, then okay, when balancing here 2 moles of H2O dissociated in this one, -2 here. So obviously in this case you will not have to consider about how much oxygen get deposited. So -2 to 0. So 2 Faraday's charge will require coulomb. So 2 into 96,500 coulomb. Okay, 2.15 and 2.16. These two questions will be discussed in the next class. Okay, about this question of this one, this question is too much important. This one about which I was telling you, this question was asked in IIT examination, and there is high probability of asking these questions in the upcoming examination. Okay, today it's all. In the next class we will discuss the remaining portion of this question. Today till here only, it's all of the class. Thank you, Team Educate.